Welcome to Ekidel, where we train future civil and structural engineer. Okay, today we will be performing the part 4 of this 8-story office building live project design here in Ekidel, and we will be using Prota Structure, as you all know. So today is the part 4 of this 8-story office building, and what we are doing today right now is to perform the interactive design, because in our last video we performed the full structural analysis and design of this 8-story office building. So today we will be performing the interactive design for this building. So right now, after you're done with your first analysis and design using Prota Structure, the next thing to do right now is to now go and perform your interactive design. So to do that right now, we will now have to now first of all check on this visual interrogation. So right now I'll click on this place called visual interrogation, where I'll have to now see the members that fails and the members that are okay. So once I click on there, this will come out right now. I will now click on this place called design status right now. So I'll click on this place right now and I click on OK. So you can now see that all our colors have now changed. We are having two colors, as you can see it here. We are having green and we're also having red. Now looking at the design status right now, chart right now, this is the chart where red color shows that that member has failed, and yellow color means that it is a warning, and then green color means that that member is okay, and white color means that that member is not designed. So right now we have green and also we have red on this model right here. So looking at this right now, you can see that we have red here, that most of our columns are green. All these columns that are showing green means that those columns are perfectly okay to withstand the wind load of this on this structure. So right now we will have to now go and perform interactive design to check the reason why all these members that are showing red failed. So right now we will first of all check on this column right now. So let me check on this column right now. What is the reason why this column failed right now? So to check that right now, I'll first of all right now click on this place to check the kind of reinforcement that was used to design this column. So I'll click on this column right now. Then I'll now come here outside here, right click, and then a dialog box will appear where I'll now click on this place called column section design. So I click on this right now. Once I click on this right now, a dialog box will appear where I will now perform what they call interactive design, because you as an engineer, you have the right to change the kind of reinforcement that was used. So right now you can see that the reason why this column was failing is because this software used diameter 14 number size of reinforcement to design this column of 600 diameter, as you can see it here. So, and which is not possible. It is never possible for diameter 14 to design for an 8-story building for the column at the very ground floor, which is not possible. At least what can make this column to pass should be at least diameter 25 of the reinforcement. So right now I will want to now do that interactive design right now. What I'll do right now is first of all click on this place called select bar, as you can see it here. So right now I will now go here right now and click on what they call interactive design right now. So you can see that once I click on that select bar, it changes the bar to diameter 12, giving you a simplest bar. But right now, once you perform this what they call interactive design right now, what will happen is that here it will now use that reinforcement that is good to perform this design perfectly. So if I click here right now, you can see that all the things that is passing right now, you can see that there is still failure, and the failure is saying that section size must be increased. So right now I will now go here right now increase our section size. So it means that this column cannot be able to pass with 600 diameter. So right now if we try 650 diameter right now, if I say update right now and I go here right now and click on what interactive design to now design that column separate, you can see that there is a slight chance for this column to pass, but this column is still passing under stress. As you can see there, it has shown the reinforcement, but it is still having this column is still under stress, under axial load upper limit. You can see there still showing section must be increased. So right now I now go right now increase 675 diameter right now, and I can go and now click on what update. So the size will change. Then I now go again and click on what interactive design right now. So you can now see that this is perfectly okay. So for you to make sure that your column is okay, once you're performing this interactive design for any column that fail or for any members that fail, you must see this kind of thing right here. You must not see any warning message. Now you can see that what passed this column was 10 numbers of diameter 25 bars, as you can see it here. So right now we're gonna click on what OK, and then once we click on OK right now, you can see that this column will change to green, means that it is now perfectly okay. So right now let's wait for it to now update the new numbers of reinforcement, which it will now change to green. So you can now, if you now click, you can now see that now that this column has not changed okay, and green means okay. So this column right now is not designed right now. So right now let us check again if we have any other column again. So looking at this up here right now, you can see that we also have a column here that is showing red. So we also make sure that this column is perfectly okay. So click on this column right now to now check on what they call interactive design. So click on this column right now, right click, and then check on what they call interactive design right now. And now click on what? Column section design. Now dialog box will appear, which will now perform our interactive design right now. So this is what you must do after performing your first analysis and design in Prota Structure. So right now we'll now go and check. First of all, check for this. First of all, you do this right now and save it select bar. Then now click on what? Interactive design right now. So let's wait for it to finish designing interactive design. So you can now see that what is passing this column was 11 numbers of 25 diameter bar. So you cannot go here right now and click on what? OK, and then click on what? OK. So with this right now, this column right now is not perfectly designed right now. You can see that right now. If we click OK right now, it's OK right now. So right now, let us go and check right now our beams right now. So checking these beams right now that are red, as you can see it here, red color means failure. So go right now and click and check on this beam right now. So click, we'll find a way to click on this beam. Right now, click on this beam right now. Then go here right now and right click, and then go and click on beam section design. So right now, now click on what they call beam. This dialog box now appears right now. You can see that just click on what we select. That's okay. Now you cannot see what is showing right here because we have a wall here. This is a concrete wall. You can see here 3W. W means wall in Prota Structure. YC means column, and B means beam. So right now you can see that this beam is failing at the top reinforcement. You can see that the area of reinforcement at the top is not sufficient. So right now we will now increase here right now to 4 numbers of diameter 25. You can see it there, and then increase this one also to 4 numbers of 25, as you can see it here. And this is okay because you can see that okay, we can make it here to be 4 because okay, this is okay. So right now I've already explained a lot for you guys. If this place is showing red, this place, once the value is more than 20 millimeter, it is perfectly okay. Right now we are having 26 millimeter because this place shows that this is a chipping size. So like the size of aggregate is 20. So if this place is less than 20, it is not okay. But right now it is perfectly okay. So this is okay. So but if this place is less than 20, you are meant to go and increase your depth of beam. But right now, since this value is more than 20 millimeter, it is okay. So right now I cannot click on what? Okay right now, and immediately that beam will change to green, as you can see it here. So this beam right now is not designed perfectly. So this is what you do for all the members that are showing green. So if you are following me in this design, because this is a live project, as I said before, you have to now go and check your own beams and make sure that all the members, beams and columns are showing okay. So right now we now go and click on what? This place right now. So I'll check on all the colors, all the members that are showing red to make sure that they are okay right now. So right now I'll just click on what? I'll just click on yes, and then right now we will now have to now go and start changing, increasing the numbers of reinforcement on the areas which are not sufficient. So let's just wait for this right now to finish. Okay, so right now we can now see what is happening right here. So this place is okay, and if I don't want here to be 25, I can decrease this to 20 and then increase the number of reinforcement of the number of bars here to be at least okay. This is 3 is okay. So I can now go here right now and then check again here at this place right now. This place is not okay because it's showing red, as you can see it here. Means that this still is not sufficient. So I'll go right now can increase to what? Diameter 4 numbers. So this is now okay right now. To know more about how to change all these bars, check on my previous videos. I've already taught a lot on how to change these bars. So right now I'm gonna click on what? Okay, because this is now okay for me. Okay, so right now we now go ahead right now for the next one. So once this is completed, okay, this is now okay. You can see that it's not showing green. So go again right now and check on this also. So you must make sure that all your beams, all your members are showing green before you can now start producing your structural detailing. Okay, so right now we now also check this for this beam here right now, and then it allows, okay, click on okay right now again. The same thing where we did here to be 4 numbers. Okay, now this is now okay, but if I don't want it to have a second layer of reinforcement, I can remove this right now, and then okay, if I remove this, it's still failing here. I can make it to be 4 and then decrease. Okay, this is okay, then make it to be 16, and then okay, this is now okay. Then here right now I can decrease this bar to 20 and increase this bar to 3, or decrease this again to 16 and make it to be 4 numbers. It is still okay, and this is already more than 20 diameter, so this is okay. So I can click on what okay. Okay, so right now again, I move again right now to now go and check on this one. You can see how I'm taking my time to check on all the members which are failing. So this is what you must do. You must check on all the members that are failing before you can now say that your structure is perfectly okay. Before you can now start producing your structural detailing, and then begin to now use your stone bridge structural detailing to now perform your structural detailing. So right now click on okay right now, and then right now once this process is done, I can now go and change the bars which are not okay. So this is the step you will take to perform your full structural design and also analysis. Okay, so right now I go again right now to check on the members. This one I don't want it to be 25 diameter. I want to here to have diameter 20, so I increase the numbers of bar required here. 3 is okay because all these places are okay. Okay, I will now go again right now to check again. If nothing here is showing red on this side, this place can show red, but if the value is more than 20 diameter, if the value is more than 20 millimeter, then it is okay. Okay, so I'll just go right now and then go again and check everywhere again. All here is okay. No one is showing red on this area of steel, so I can click on what okay right now. So you can see how we are doing this right now to now check all our members one after the other on the one that are showing that I'm showing red color, which are failure members. Okay, so right now I'll just click aside right now and then palm down to check on other ones also. Let me check on this place right now. I can see that we have a failure here, so I check on this right now and I check on this, click on this right now, right click and then say beam section design. Okay, so right now I'll check on this right now and then check on this again right now, and then I'll now go right now to now go and check on the members failing. You can see that this is not okay, that this diameter of 32 is too big. Never allow, I would say that you should never use a diameter of 32 for a building, or except you're building up to 20-story building or 15-story building, they can now begin to use diameter 32. But for a normal story building of at least 10-story building downward, I would say that you should stick with diameter 25. And if there is any failure, like I can see right now, we have increased to 4 and we are still having failure. Let me increase to 5 right now. I can see that it is still having failure. So right now, I will now increase my depth of beam, and which I'll do just here right now. So I'll increase this depth of beam right now to be 650 and see if it's okay. But not to waste my time, I will use diameter 750 beam of 750 depth. So I'll go right here right now and then change this beam depth to 750, as you can see it here. Change again 750, and this 750, and this also 750, and this also 750 right now. 50, okay, and then go here right now and click on what they call interactive design, and then check on this place effect manual edit. Once you change any depth where you're performing your interactive design, you have to go to this place and check this effect manual edit, else it will not work. So you can now go right now and click on what okay right now, and then go here right now and now click on what steel members. So once you come back here right now to this place right now, you just click on yes for it to take the effect of what you have changed. So you can now see that our beam depth now becomes 750 and no more 600. So once this is done right now, you can see that you can see that this place that was failing right now is now okay. So right now go here right now and increase this right now to at least 4, because never allow, the reason why I increased it was because this was 45. I can see it here, that area of reinforcement here was 45, and I always say that you should at least use up to 75. So right now, since it's showing 45, I will add numbers of reinforcement to be 4, and which now should be 246.54 millimeter square. So that's okay for me right now. So right now, I now go here right now to now and increase this place right now to the 20, and it will show failure here. I'll now go right now and increase the numbers of the second bar to Y20. As you can see, there 20 diameter, and then this is okay because it's already more than 25. That's okay for me. So I'll now go right now again right now to now go and check again where I have a failure. Here also, I decrease this right now. If I don't want this, decrease this to 20, then increase this right now to 4 numbers, and if I see failure, I'll now go right now and go and add second layer of top bar. I'll just add here to 20 or 16, and then increase and then add the numbers of bar to at least 2. So then go here and then choose here bar layer to be 2, second layer. Okay, I've already explained a lot for you guys. So if you have any issue on this place, watch on my first video or go to my playlist where I say full structural design using Prota Structure, and you will know more about this. So right now, this is now okay right now because everywhere is okay on this area, and this values here that is showing red on this area where I'm having space and bar spacing is already more than 20. So this is okay for me, and we are right now on what okay. So that being right now will now be shown green, showing that that beam right now is now okay. So this is what you're meant to do as a civil and structural engineer if you're using Prota Structure for your design. You have to check your beam one after the other, even those ones that are showing green. Check it to know the kind of reinforcement this software used to design your beam and your columns and your slab or your structure for you. Because if you don't check it, you might have issues during detailing. So right now, I will just say let it just finish changing all the size of that beam line to 750. So right now, I will say that please, if you have not clicked on our subscribe button, I will say you should click on the subscribe button, and because we will be performing a pipe foundation for this structure. So right now, if I click on outside right now, you can see that this beam right now is now okay. So right now, I'll go again and check again on this beam also. Let me check on this one right now. I'll click on the beam right now, and right click again and check on what beam displays. Okay, right now, and then the dialog box appears right now. Okay, like I was saying before, we will use a pipe foundation for this structure. So if you have not subscribed to our channel, I'll say you should not miss this opportunity, because we will be teaching more and more about structural design. So right now you can see that if I come here right now on this beam right now, this is failing, this is showing 32, and if I try to decrease to diameter 25, here I'll be failing right now. So I'm not going to increase my depth of beam to 750 or 650, but I don't want to waste my time to now start changing beams and depth of beam every time. So let me just go and choose beam, because from experience I already know that what we be able to withstand the load on that beam is 750. So I will always say that if you are following Ekidel, just give yourself within the next 2 years, you will have all the experience as a civil and structural engineer, where you can now determine the size of beam that will be able to pass a beam, or that will be okay for a beam perfectly for a design without even you performing the structural design. So right now, just click on this okay right now, and then go ahead right now and now click on once it's done right now, start changing my bars, numbers of bars, and all that. So right now, like I said before, I would take to be 20 right now, and then increase this right now to 3 numbers. If I to 3 numbers 20, and that this now will be okay. Okay, so right now, okay, this is still lower than 75, so I'll go right now and do this. Most people accept that, but me, I don't accept that. I like to have my area of steel to be at least lower than 70, higher than 75. This is not also okay because this is showing 47. I'll also increase this to 20 and check what okay. This is now okay right now. So right now, when I go again right now, these are all okay because they are more than 20. So I'll go again right now to reduce this to 20 and see what's happening right now. So I'll now go again right now and add a layer right now, decrease this to 20 or 16, and then 16, and then increase my numbers of bars to at least 3. And if it's failing, I'm not going to increase to the size of bar to 20. So I'll check 3 right now, and then go here and change the layer to layer 2, because this will be layer 2. Soon I will be taking you guys to site to show you guys this how they place this reinforcement on site. But for now, let's begin our design first. Okay, so right now this is now okay. You can see that all the area of steel area right now, they are all okay, as you can see them here. No one is showing red and no value is below 75, as you can see it here. So right now I'm not clicking what okay right now. So that beam right now is now perfectly okay. So right now I go again right now to go and check the next beam. Once this other box closes right now, I check again the next beam right now, and then and so on and so forth. We will be doing that until we have checked all the beams that are in this place. Okay, so right now then I was okay, is trying to change the depth of beam, which we have just adjusted to 750, as you can see it here. So right now that beam depth, all the beam depth on that line or on that grid line, we change to 750. Okay, so let us wait for that process to be completed. Okay, so right now I will say that in my next video we will be performing the slab detailing for this 8-story office building. Okay, so you can see that this is now okay right now. You can see that. So I go again right now go and check again this particular one here. So I go, okay, just spam down. Okay, let me check this right now, this one here, and check this right now. So in my next video I will be performing a slab detailing, sorry, for this 8-story building, where we have to detail each and every floors. So you can see the reason why you need to subscribe. But if also you don't want to subscribe also, I would say you can leave it. But the reason why I would say you should subscribe so that you don't miss the video when we are going to post the video. Okay, so right now I just increase this to like 4 numbers and increase to 25, and then decrease this right now to 3, and then remove this. Let me see that. Okay, this is to be needed. Okay, so I will leave this to 2 because it's already more than 75 here. So these are all okay right now. I will not click on what okay. Okay, so right now we are done with that particular you can see that this is not okay right now. So except your beams or except your members show green, that is not okay. But right now, since it shows green, it's not okay right now. So I check this on also right now, and then check on this beam section design right now to check the beam, the kind of reinforcement that was used to design that member for me. I will not check again right now. Once the dialog box appears, I will just say yes on this place right now and wait for the for this software to just choose its own reinforcement first before we can change our own. Okay, so let us go ahead right now. Let us see what, okay, it gets all this right now. I don't like using 2, I like to make it 3, 20. If it, okay, you can see that this is now okay. So right now I go right now to now and change on this place right now to check if everywhere is okay here. So this is okay, perfectly okay. But this place right now is still okay because it is more than 20 millimeter. So I'll just right now click on what okay right now. So we have checked all that beam on that line, and which is perfectly okay. So you can see how we are taking our time to teach you guys here how to use Prota Structure to perform your structural design. So you can see how far we have gone. Remaining, let's check on this right now. You can see that this one also is having issue. It's as if it's hidden, but no way we are seeing you right there. So you can see how we are doing. Okay, so we check. Okay, click on that beam right now, and then right click and then say beam section design. Okay, so you can see how you are doing right now. You can see how we have modeled this building from scratch, from the ground floor down to this level. And I'll say that this is a live project, so that is why you are meant to follow it up, because even when we are performing during the construction, I'll also be showing you videos on how they're tying those reinforcements, so you can see the reason why you're meant to subscribe, because this building is for at least 2 to 3 years duration. So I'll be updating you guys on this structure while we're performing all the construction. So let us check right now and do this right now, and then go here and then check the piles that are okay. Okay, right now I go right now to decrease this right now to 3 numbers. Okay, 4 will be okay. 3 was not sufficient, but 4 was sufficient. Okay, so right now go here right now and decrease this to 4 numbers again, which will be okay, because once I decrease now to 3 will be failing. You can see right now 3 is failing already, so 4 will be okay, because this beam is like a critical beam. So I go here right now again and decrease this to 4 will be okay on this side. 4 will be okay, that's it. Okay, here again 4 will be okay also. 4 will be sufficient. 3 will not be stable. You can see that this is giving you 1.58 area of steel, which is not okay at all, because any mistake that this beam will fail. So it is always good to have your value more than 75. area of steel. Okay, so right now this is not perfectly okay. I can click on what okay right now. Okay, so right now you can see that we have already gone far. We are almost done checking all our beams on this 8-story office building. Okay, so right now let us go ahead again and check again what we have again right now. So once this finished right now, no changing the depth of that beam, you can see that it's trying to change the total beam. Okay, so right now you can now see that this is not perfectly okay right now. Okay, so now to go again right now, there is something showing red on this other side again. So we go here right now again and check on this other side again. We are having red on this side again. So we go right now and then check also on this beam. This beam is showing red, you can see that. So we'll check on that beam, this one also. Let's check on this one first and then check perfectly on this right now, and then check the beam that are all showing red on that area. So we'll check on that right now and then go here right now. Once that dialog box shows, we say yes first and then allow the software to check the side of reinforcement that will be suitable for this beam. So okay, so right now let us go right now and check. Okay, so it has given us the sizes of reinforcement which in my own side it is okay for construction. So these are all okay right now. You can see that. I will now go here right now and say what okay. So right now again, I go again right now to now go and check the next one showing red. Okay. Okay, this is now okay. So let us check on this one here. You can see that this is showing red, but you can see it's trying to hide, but no way we are seeing that right now. So you must check your beam one after the other, because if you miss anything here, that means that member will fail, and when that member fails, it might cause collapse of the particular building. So that is why you must check when you're performing this stage, what they call iterative design. You must leave every other phone. Forget about your phone. Don't use your phone and start chatting and be checking on this, because any mistake that happens here will cause collapse. So you must check on. You can see that this is showing 0.48 area of steel. So I'll have to go and increase the size of bar to at least give me a good size to at least 75, 175. Okay, this is not okay right now. So you can see how I'm checking my beams one after the other, because this is a live project. That's why I am not I'm checking all these things one after the other. Else I would have just say you guys should just take the first step which I took and then just conclude it. So you can see how I'm taking right now. So once you're performing this stage, make sure you avoid distraction, because any form of distraction will make you to miss maybe one of the members which is failing, and maybe you didn't see it very well, and then you just go right now and then produce all your details, and which they will use for the construction, and then boom, all you just see is collapse during the building, and that is what causes collapse. What causes collapse is just a minor things which would have been avoided during the construction, during the design stage. So you can see how you're taking our time right now to not check the side of reinforcement, which is okay. So you check off all this. So let me reduce this. I don't want 25. Let me check it that to be okay. And let me increase this to add a layer for this, because 25 size of reinforcement is way too costly for most clients to afford. So as you know, we don't just design our building to stand. We also consider economy of also to save money for the clients. So this is now okay right now. Okay right now. So you can now see that here on Ekidel, we are not just teaching you just to design, we are also teaching you how to also economize material to be able to for you to win that contract. Because for you to win the contract, you have your design must be suitable, and also it must be economical. So let us check this also. You can see that this is also failing right now. So check this right now. So you can see how we're taking our time to check each of these beans. If this was not a live project, I'll just do one of the checking and then ask you to go and check off for you. So that is why you have to follow Ekidel, and also and also share our videos so that your friends, your colleagues, your classmates and coursemate can also benefit from what we are doing right here on Ekidel. Okay, so you can see. Okay, so right now I go again right now and reduce this to 20 and then add numbers of layer. I know most of you will be confused on this numbers of layer as I'm doing right now, but in my coming video I'll be showing you what this really means, where I'll use diagram to show you how to place this double layer of reinforcement on construction. And if need be, I can also take you guys to site and show you guys what how this will be placed during construction. Okay, so right now, go right now, click on what? Okay, because everything is now okay right now. Okay, so I'll go and okay right now. And then again, we go again right now. You can see that there is a red symbol here. So we just go, we have checked for all we have checked for this eighth floor, and everything there is okay. You can see that there is no red, there is no members that are showing red, which means that all members at that 8th floor is okay. And also at 7th floor, sorry, you can see that 8th floor it is all okay. You can see that. And also our 7th floor also is also okay. You can see that all members are okay. And also our 8th floors are perfectly okay. And you can also see our concrete walls also, as you can see them here, is perfectly okay. So right now let us go on this place, which is the this floor. This floor is 4th floor. You can see there. So let us check this beam because it's like it's failing right now. So check on this right now, and then go and check on this right now to check the kind of reinforcement that was used on that beam, why it is failing. Okay, so you can now see that civil engineering and structural engineering designs is not that easy. All you have to do is to just follow the guiding principles and guidelines. And if you have a good coach, like as we here on Ekidel, we are good coach because we have over 15 years experience in structural designs and also civil engineering designs and also construction. Okay, so right now we just check on this right now, and then go over and check on this. These are perfectly okay because everywhere is okay, and the set of reinforcement given to us is perfectly okay. And okay, this is okay. We cannot go right now and click on what okay right now, and then we go ahead right now and then check on the next floor, which is the 3rd floor, if all the 4th floor members are okay. So let us check if the 4th floor members are all okay. You can see that they are all okay right now. So let us go and check on the 3rd floor, because 3rd floor we are having one beam failing here. So you can see how we are taking our time to check on this beam and all the structural members one after the other. You can see how we pass through columns and make sure that all our columns are okay. Now we are checking our beams and measuring to make sure that everything is okay. So we are taking our time. Now you can see that in this place right now, they're okay. Now this is okay. So right now, let's just check this right now. And if there was failure on this link right now, I would say that you should go and increase your depth of beam, because that's what causes the failure. If your depth of beam is too small, you have to go and increase your depth of beam. In my coming video, let me say by September, I'll show you guys how to adjust these links when there is failure. I'll have to use a structure to make the structure to like fail in terms of links, and then show you how to adjust that. So right now this place is lower than 75, so I increase this to 3 numbers. This is okay, and this place was this is 49, which is lower than 75. I'll make it to be what 4, and that's okay. And this place right now, I'll make it to be what reduce this right now to be 20, and then increase to be 4, and then go here and make to be 20, and then increase to be okay. That's okay right now because it's already 25. Let me do decrease to 2. This fading to 3 is okay. So right now, just say right now okay. Okay, so right now I now go to the next one right now. You can see that the 3rd floor, this is 3rd floor we are. 3rd floor is perfectly okay. So you can see that this is story 3. You can see that story 3. So everything here is okay on story 3. Let us check perfectly first. They're okay. If everything there is showing okay, you can see that they're all okay. So right now we now move right down to the story 2 to now go and check our story 2 right now. So check on this bin. This bin is showing yellow. You can see this bin shows yellow color, and yellow color in this place means warning. It means that that bin is partially okay, but you have to make some adjustments. So that's what yellow color simply means on your structure. So right now, go and check on this place right now, and check on this right now, and check on what beam decision design, and check on that beam why it is showing yellow, and then try to adjust the reinforcement or the size if the size that is causing the issue. Okay, so right now you can see that there is a deflection failure right now. So once you have deflection failure here right now, the first thing to do right now is to first of all adjust your reinforcement, and if it's not okay, the most method is to go and increase the depth of beam. So right now you can see that what is giving me here is that 13 numbers of reinforcement, which is not okay. So right now I'm now going to increase to what 20 first of all, or 16, and make it to be 4 numbers here. It is still failing, and make it to 20, and then check if that will be okay, and 20. That's still failing. So right now, what I'll do right now, since I'm having what they call deflection failure, you can see it there, I'm now going to increase the depth of this beam to 750. So I'll go right now and change the beam depth to 750 right now. Okay, 750 and 750 and 750 and 750. Sorry, 750, 750 and also 750. And once you're done with changing your depth, first to do it, don't say okay or don't click here, else this size will not be affected in your design. So you click on this place called interactive design because you have made changes. So go right now and click on this what we call effect manual editing, because we just changed this depth manually right now. So click on this right now and say what okay, and then we can now go here right now and now click on what steel bars. So well, let's wait for that size. We can see that all the size right now is now changed to 750, and let us now begin to adjust our size of bars right now. So you can see that there is a failure on this place right now. You can see that this is failing right now. So if we change it right now to like 4 numbers right now, you can see that it is now okay right now. So this is now okay. You can see that right now. So we can now go here right now, and if at all this place was still failing, we're going to increase our beam to at least 850, and if it's still failing, 900, as you can see that. So right now we're going to go right now and go and change this place to 16 numbers will be okay for this place. 16 the diameter of bar will be okay for this place. So we'll go right now and change from 13 to 16 right now, and make sure you're checking all these areas of bar if they are 175, which is okay. And then we just go right now and then check on all the spans and make sure that everything is okay, because this is a live project. That's why I'm taking much time. You can see it here. Okay, so let us go right now and then check on this also. So here on Ekidel, we teach mainly with live project because we are a design firm right here, and then we use this live project to teach right here on Prota Structure. So right now we go right now once they are on this level box closes, and then check if that beam is okay, which of course it will be okay because we have done all our checking right now and it must be okay. So right now let's just check if what I said is just okay. Okay, let us wait for this for the depth of this beam to be adjusted on this model right now. Okay, so let us wait for it to be done right now, and then let us go ahead for the next to now go and check on the ground floor. Okay, so let us wait for it to finish right now. Okay, so like I said again, please, if you have not subscribed to our channel Ekidel, I would say you should use this time to click on the subscribe button so that you don't miss our coming video for the pipe foundation for this structure. So right now we now go right now and click outside to check right now. You can see that this beam right now is now okay. So right now we just zoom out right now and then check again for all the floors right now, and then go to the last floor right now and then zoom out everything to see everything if it's okay. So right now let us now check our structure perfectly to check if everywhere is showing green. You can see that all our members okay. You can see that there is a member here showing red. You can see that. So let us go and locate that member right now and then change that member, and then check what is filling that member, and then try to adjust the size of that member or adjust the reinforcement. So let us zoom in right now to that place right now, and then check at that place right now. Click on that place right now, right click, and then check on what they call beam design, because beam, what is failing right there is beam and not column or wall. So check on that beam right now, and then you can see that this beam depth, maybe during our model we use 500 instead of 600. You can see that that's what causing that failure right now. So we have to adjust that this beam depth if the beam depth is what is causing the failure. So you can see that we have a lot of reinforcement numbers here which are not okay. So you can see that what causing that failure is the size of the depth of the beam. So we'll go right now and change that 500 to be 600 right now. So do this right now and then click on what's here, and then click on this place and then okay, and then go here right now and then go to this place right now to now and check, now and change your reinforcement. So we can now go right here right now and then click here, and this is update first, and then go here right now and then try to change your size of reinforcement right now, this to be 20 if that's okay. And then we go here right now and then I can make this to be 20 and increase this to be 4 because it's not really that good to use 25 because of the cost efficiency. Okay, so right now you can see that this is now okay right now. This is already more than 75 area. Okay, that's okay. So right now I'll now go and check again on this place again if the area is okay. So this everywhere now becomes okay right now. To know more about what I'm doing here, check on our playlist where you have a playlist called full design on Prota Structure and click on that, watch those videos, and you will learn more about it because we explain more on this area. Okay, so right now click on what okay right now, and then you can see that that beam member will be perfectly okay, well designed, and it will, and the color will change to green. So let us wait for this thing to finish right now for it to change that depth to from 500 to 600. Okay, so thank you for okay right now. Let us click outside right now to now go and check if it's okay. So check on this right now. You can see that okay right now. So let us check on our members again. First of all, on this model, let's check on our members first of all, and not only you rolling your mouse button all around this place to check if everything is okay. You can see that everything is okay right now. You can see that. To not tell you how serious I am, to make sure that all your models must show green right now. We don't just stop here right now. We go over again to now go and check again from plan view. So check again from plan view, viewing it story by story. So let us go right now to check on plan view again, not only on model, because some things might be hiding here, but if you check it on plan view, you will see that nothing will be hiding. Okay, so right now click outside right now. You can see that everywhere is showing red, showing green. You can see that even our walls are all showing green. You can see that. So right now we are on the first floor, which is story 1. Everything showing here is perfectly okay for story 1. So go here right now again and check on what they call story 2, and then check for story 2 again. If story 2 is perfectly okay again, you can see that story 2 everywhere also is also okay. There's no one showing red. This red you're seeing here is not red. This red is like a borderline for this wall, because this wall is set as a red color for a borderline. But if you zoom in right now, you can see that on this wall it is showing green right now. So this red you're seeing here is called a borderline for the wall. That was how it was set on this Prota structure. So you can see that everything here on this second floor is showing green, which is okay. So begin and check story 3 right now again, and then let's check again if it's okay again. So you can see that story 3 again right now is still okay. Then story 4 again, you must make sure that you check every story and make sure everything is showing green. It is when it is showing green that your structure is perfectly okay. Then check on story 5. Let's check again if it is okay again. Story 5 is also okay, and check on story 6 again. Story 6 again is also okay, and check on story 7. Story 7 is also okay, and check on story 8. Story 8 also is also okay. So you can see that how we have checked our story one after the other from story to make sure that everything is perfectly okay, that all the elements are perfectly designed. So now we can now go back to our plan view right now, and then perfectly to see this. Now most of you have been asking where is the staircase of this building, and also where is the lift for this building. Now the staircase is not attached, is not inside the building, but it is outside the building, and also the lift is also it is also independent. It is outside the building. So after we are done with our pipe foundation and also detailing, I will now go and design that staircase separately, and also design the lift separately, and I'll show you guys how we are doing that design. So right now you can now see how we have designed perfectly designed and checked our structure one after the other, and make sure that all our structural elements is perfectly okay. So this is how to perform your interactive design after you are done doing your first design and also analysis. So you can see how we have done this stage one after the other, and you can see how everything went. So this is how to check your structural members after you're finished designing your structural elements. So you must make sure that everything is okay, and for it to be okay, they must show green. None of the members must show red, yellow, or this orange or white or blue. It must show green. Green means that okay, you can see that everything here has its own name, but only green that shows okay. And you can see how everything here is showing okay. So we have come to the end of this video for today, of this training for today. Now for what we are going to do next week, just to carry you along, next week on this structure will be when we have to go and detail the slab reinforcement, and I will show you how to detail a slab reinforcement. Know that we have on this place, we have a roof slab, and also you can see that we have a roof slab, and also we have a solid slab. So I'll show you how to detail a solid slab and also a roof slab. And also after we have done with our structural detailing right now, we will now transfer all the details, which is the column, the beams, and the slab structural detailing, to now transfer it to AutoCAD, where I will now use our Stonebridge company detailing template to now start showing our structural detailing one after the other, which will now present it also for printing. Then we will now come back right now to now go and perform our foundation design. So you can see that we have a lot of things to do, because this is a live project and we have a lot of things to do on this project. So if you have not subscribed to our channel, I would say you should click on the subscribe button so you don't miss all our coming videos. And also, if you want to get all the parts of this video, I would say you should check on the link down below, or check on the playlist called 8-Story Building Design. So check on that playlist, you will see all the parts of this video. So thank you so much for being a part of this lesson for today, and God bless you all. We love you and we love you also.